Hello, my beloved viewers. Today, we will be trying another problem to solve. And we have our Cele, Hydraulics and Geotechnical Engineering Board problem number 3. Let us now start solving a problem. First and foremost, please allow me to read the situation in our given problem. A sample of saturated clay was placed in a container and weighed. The weight was 6 newtons. The clay in its container was placed in an oven dry for 24 hours at 105 degrees Celsius. The weight reduced to a constant weight of 5 newtons. The weight of the container is 1 newton. If the specific gravity of the solid is 2.7, determine the following. First, we have to look for the value of the water content. Second, the void ratio E. C, we have the moist unit weight. Then coming up next, the dry unit weight. And then lastly, the effective unit weight, or sometimes we call it as the submerged unit weight. Let us now start solving the problem. But before the calculation process, allow me to read first all the givens that we have in this given board exam problem. First given, wet weight plus the weight of the container is equal to 6 newtons, followed by the dry weight plus the weight of the container, which is equal to 5 newtons, and the weight of the container is actually 1 newton, specific gravity of 2.70. But of course, the wet weight is somehow reduced to 5 newtons because of the 1 newton weight of the container. But of course, similarly, the dry weight is equal to 4 newton because of the 1 newton weight of the container was reduced originally from the 5 newton of weight dry plus weight container. That is how do we get weight dry equals 4 newtons. Let us now proceed to the first item of our problem, that is to calculate for the water content. And of course, our formula for the moisture content is equal to wet weight minus dry weight all over dry weight times 100%. Let us now proceed to the direct substitution. And now our moisture content is equal to 5 minus 4 all over 4 times 100% for a moisture content of 25%. Finally, our moisture content is equal to 25%. Coming up next, let's try to solve for the void ratio. And this is the formula that we are going to use. We will be using the degree of saturation formula S equals to Gs times W all over E, since no other formula except this one is available. Now, by using this formula of degree of saturation, let us solve for the value of void ratio E. That is why we have transformed the formula into this format. E is equals to GSW all over S. Doing the direct substitution process, we have now our solution as void ratio equals to 2.7 times 0.25 divided by 1. Converting the value of moisture content 25% to decimal became 0.25, while our degree of saturation, assuming 100%, that is why we have used 1 for the value of S in this calculation. Finally, our computed value for the void ratio is equal to 0.675. We can then now proceed to the third question in our problem, that is to compute for the moist unit weight. And our formula for the moist unit weight is equal to specific gravity times unit weight of water times 1 plus moisture content all over 1 plus void ratio. Doing the substitution process, we have now our equation as moist unit weight equals 2.7 times 9.81 times 1 plus 0.25 all over 1 plus 0.675. Finally, the value for our moist unit weight is equal to 19.76 kilonewton per cubic meter. Let us now proceed to the dry unit weight. Solving for the dry unit weight, we have our formula as dry unit weight equals moist unit weight over 1 plus the void ratio. After the substitution process, we have now dry unit weight equals 19.76 over 1 plus 0.675. Finally, our answer for the dry unit weight is 15.8 kilonewton per cubic meters. Let us now proceed to the last question in the given problem. We can then calculate now for the effective unit weight or the submerged unit weight. And the formula that we will use so that we can calculate for the effective unit weight is equal to saturated unit weight minus moisture unit weight. Right after the substitution process, our effective unit weight or submerged unit weight now equals to 19.76 minus 9.81. Finally, our effective unit weight or submerged unit weight, our answer is equal to 9.85 kilonewton per cubic meter. Thank you very much and God bless us all.